Audio Jungle. Audio Jungle.
This is a precious video of VIW AG workers initially building the Obervermont 2 underground power plant between the Silvreta Reservoir and the Vermont Reservoir. Inside this tunnel is where giant transformers up to 200 tons are reached. Workers here are pouring the first concrete blocks and making sure that the transformers will stay there. Outside, the steel frames were carefully woven together before they proceeded to concrete the roof leading to the tunnel. Workers drill holes to put explosives in. This demolition will help connect the machine cave and another tunnel. The company Kremsmüller was commissioned to manufacture water pumps. The metal sheets will be bent and welded together to form large spirals with a diameter of about 9 m and a weight of up to 100 tons. Back to the tunnel through the mountain. After removing 200,000 cubic meters of rock, 100 m of the tunnel was revealed. But in order to connect smoothly with the above, they need to create an explosion right at this location. A large explosion was generated and the tunnel was cleared to connect the inlet structures to the lake bed of Silvreta. Elsewhere, sheets of metal up to 34 mm thick are being fed into machines to bend them to form pipes 45 meters in diameter. With a weight of up to 45 tons and a slope of 48 degrees, the laying of pipes like this requires very modern machines. Once the pipes are fixed and electrically welded together, they will proceed to pour 2,500 tons of concrete to fill the gaps after the pump has been placed. And so on. The next steel pipes are carefully welded by them and then placed in the tunnels that have been dug before. Next, they used a light excavator to dig up the rest of the cave with a diameter of 18 m, then they drilled and placed explosives to create an explosion enough to break the remaining wall. As said, Obervermont Work 2 was built as a parallel mill to the existing Obervermont Work OVW. With the construction of OVW2, a new pipeline for the existing Obervermont plant was also created and the existing above-ground pressure piping was removed as a compensation measure. The pumped storage plant utilizes the slope between the Silvreta and Vermont storage facilities to store the circulating pump and thus makes a decisive contribution to VIW AG's hydroelectric efficiency increase. The convoy carrying the spiral pump has arrived. Because each one weighs more than 100 tons, the transportation must use specialized vehicles and have a lot of experience in long-distance transportation. Next, they will proceed to make a concrete rack to put the crane rail on it. This crane rail is responsible for moving the water pump device to the position they want. Once the concrete supports are dry and secure, they will proceed to install the crane rails and test run them before lifting the pump equipment into place. The real test of the crane outlet is the now completed turbines and the helical pump heads, with a maximum load of 180 tons per crane rail, lifting one pump head. The helical pump heads will be placed in their correct positions thanks to the precise micrometer calculations by the assembly companies, ensuring that the two couplings will be properly fitted together. This is the tunnel where large cables are placed to conduct electricity from the transformers to the outside, where workers are carefully reinforced with thick concrete layers to prevent water from entering. The path of the cable is also an escape route. The path of the cable and the tunnel is covered with asphalt. This place is also called the transit between the cable car and the Silvreta SI in winter. At an altitude of 2000 m above sea level, which is considered the highest of the power plant, workers are concreting the drainage road when the Silvreta lake is overloaded. Therefore, the walls in the tunnel are carefully reinforced, the welds are welded together and then checked again after the assembly is complete. This tunnel has a length of about 300 m. This is where the sockets are connected to the transformer. Everything is completed when the tunnel is covered with a thick layer of concrete to prevent the penetration of water into the connecting equipment compartment. Next, people will pour concrete to cover the entire pipe wall from bottom to top. Because the pipe is very deep, the concrete transportation is completely dependent on the winch ladders. Next, people will pour concrete to cover the entire pipe wall from bottom to top. Because the pipe is very deep, the concrete transportation is completely dependent on the winch ladders. The inside through diameter is related to the chronic delay of the transition of the two shaft sections, and the entrance of the side compartments prior to the concreting must be intricately shaped in the end with equals. This is the route where the power cables are transferred. Because the area is quite steep, so the installation takes a lot of time. After completing the installation of the energy transport route, followed by transporting the cables to the construction site, workers will then untie the ends of the cables and hook them to the ends of a tractor located nearby. Cable pulling begins. One by one, the cables are pulled inside the tunnel and will end at the exit of the Verbundbahn Das Mountain station. At this 3 km long tunnel they will proceed to pour concrete to create a coating, but first to do that they will use this road surface grinding machine. In the area where 2 transformers are placed, concrete is also carefully poured. In addition, this area is also the place to place switchgear. The 2 units are also gradually completed and are expected to go into operation at the earliest, although the mountainous terrain is quite complicated. But thanks to a team of experienced engineers, the project has reached the schedule and surpassed the people's expectations. Congratulations on the project.